Hello, welcome to my talk. My name is Dylan Tupy. My talk is called Terraforming Your Cloud. So it's basically around the tool of Terraform and how to use it within your infrastructure as code and your DevOps toolchain. So as I said, my name is Dylan Tupy. I'm a cloud infrastructure engineer here at Cognizant Softvision. I'm in the cloud and DevOps community. And our agenda today is going to be, what is Terraform? If you're not familiar with the tool, maybe you've heard of it and thought that sounds cool, I'd like to come learn about it. So I'll go over, what it is, how you use it, and then I'll go over the basics of it, what you're going to need to know to use it, how to set it up, some of the very basic things. And then I'd like to compare the versions that are available. We have a couple of different flavors we can choose from. And then I'd like to do a demo, a quick demonstration of some of the UI you'll see. I have a couple tabs open to show you a couple examples. And then we'll have a little bit of time for Q&A. So that's how today will go. So the first question, if you're not familiar, is what is Terraform?
Recording in progress.
This is a quote directly from their site. Terraform is an open source infrastructure as code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. Terraform codifies cloud APIs into declarative configuration files. So with that statement, there's a couple pieces in there that we kind of need to break down to understand what they're referring to. So on the side here, you see a couple of those terms that we discussed there. One of them being infrastructure as code, or with some of the room for slides, IIC, as you can see there. So what is infrastructure as code? It is the process of managing and provisioning computer data centers through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. So why do you want to use infrastructure as code? There's a handful of main reasons you want to. A lot of it is around cost savings and reducing errors. So with IAC, you can reduce your time to build and deploy infrastructure. While doing that, you can get your builds consistent based on the code you wrote. So you're reducing the human errors. So as long as your code doesn't have errors, you should be doing better than before. And again, the cost and speed and the effort really come into play there. You're not spending a lot of hours deploying infrastructure. You will spend man hours writing the code, but once you write the code, you can deploy it hundreds of thousands of times based on that code that you spent time on. So that's kind of the main pieces of why you want to bring in IAC, and Terraform can help with your IAC. And another thing that it talks about is declarative versus imperative. So the Terraform language is declarative. And what that means is we describe our intended goal and what it should look like at the end rather than the steps to reach that goal. So in Terraform, what you do is you say, this is what I want my virtual data center or my resources to look like. I want 10 VMs and 4 networks. And that's the intended goal. So that's what you'll get after running your Terraform code. Another big thing in IAC type tools is a push versus pull mechanism. Terraform, and again, with the limited slide room I have, you'll be seeing it as TF potentially later. Terraform uses the push method, where once you commit your Terraform code or run your Terraform code, that will push the configuration into your connected clouds or on-prem resources, and then it'll run what you're looking for. And that's that. So I can't see everyone's faces and know what errors they came into IT here, but why would you want to use IAC is, in the past, to set up your infrastructure, you had a lot of you'd have to go buy physical servers, you'd have to get them delivered, rack them in your server room, set up networking, and then log into them and get your apps and code running on them. So that was not fun. That was a pain. There was a lot of man hours lost. So the next thing we kind of went to was virtual servers, and that was fun. you saved a lot of time and money and effort, but you had to virtually build these VMs. You had to log into vSphere and deploy templates. And while that was simple then, again, deploying hundreds, if not thousands of servers, it was a pain. So now we're living in the cloud. A lot of people are living in the cloud. It's where a lot of people want to go. And the cloud offers a lot of different resources, not just virtual machines. They offer a lot of platforms as a service, other services as a service. And so you can take advantage of a lot of things, but building these things out in the GUI, while is easy and fun, again, if you want to build hundreds or thousands of resources, manually clicking through the GUI is going to be a lot of time wasted. So what we want to do is you want to use infrastructure as code. And like I said, that's writing code to build these resources for you. It's automated, they're consistent. These builds are based on templated code. So you can have a single set of your code that is templated that you can import or render your values and variables as you go for your specific environments. So they all can be based on one code. So your dev will match your QA will match your prod, and the variables you put in, you'll be changing resources, names, subscriptions, sizing of things. So you can really manage it very nicely. So now that we kind of got an overview of what Terraform is and the background of IAC, what are the basics of Terraform? What will you need to understand to use this tool? So here's a quick overview of the pieces that I think are the essential pieces. There are other pieces out there that are bonuses or extras that you can do more with and provide more value, but these are really, from day one, these are kind of what you would need to understand to get this up and running for yourself. So we have state files, workspaces, execution plans, the HashiCorp configuration language, otherwise known as HCL, backends, providers, and modules. And like I said, that's kind of the base of what you'll need to know. So to understand these a little more, we'll break them out here. We'll start with the state file. So the state file is kind of what the name implies. It's Terraform's way of storing the configuration data for a workspace in JSON. So when you run your code, you'll build your resources, and the state file connects your physical resources to the configuration code. So as it states there, it maps the real world resources to your configuration. And the state file is probably one of the more, if not most important pieces of Terraform. When you're first starting out, you'll probably be using a basic workspace, a local backend, and we'll get to what those mean in a minute. But your state file most likely will live on your computer. It won't be secure. It won't be versioned. It won't be easy to tell what that state file was used for. And there's ways of setting this up that is recommended and also will make things easier for you. And we'll go into that in a minute. But I just want you to understand that the state file, what it does. And it is in JSON. It's a little easier for the machines to read that way. So the next would be the workspace. So as I stated in the state file, we do use workspaces, and Terraform comes out of the box with a default workspace. And that's the combination of a backend, the state file, the variables. It's kind of the whole meal. It's all in one. And I like to think of it as kind of like environments. Usually when you're working with workspaces, you kind of map them to environments. You'll have a dev environment for a dev workspace. And if you have a really big infrastructure, you can break that down further into just like an application prod workspace, an application dev workspace, networking workspaces, and that way. So it's really up to you and how big your project may be and how thin you want to slice that pie to get a handle on your workspaces. But it's really the way of working with that state file for that workspace, those variables. That's how you get them all together. The next thing is the execution plan. So in Terraform, the way it works is there's kind of an order of things. You're going to write your code, and then what you're going to do is you're going to use Terraform to run this plan. And the plan is it looks at what you want, what you have, and it says, this is what we're going to need to add. This is what we're going to need to delete. This is what we're going to need to change. And that plan really lays out the end goal and what it needs to do to get there. So Terraform does that for you. But as I said, it's a plan. It doesn't do anything. You can save that plan file, or you can use it to run, right away if you want that to run. But that's just a plan, and it lays that out for you. And the next thing, the state file is important, but I guess the most important thing is you need to understand the language you're using for this tool. So that would be the HashiCorp configuration language. And that's what you use to declare your resources that correspond to infrastructure. So these are kind of laid out in blocks, arguments, expressions, and it's declarative and idempotent by nature. In the first slide, we talked about declarative, but another good thing, with that combination is it will be idempotent. So if you have a slice of code that says, I need a VM created, and you run it, you'll get that VM. You run it again, it'll say that VM already exists. I don't need to do anything. You won't get a second VM. And it won't make any changes as long as it matches what you deployed in the first place. One of the rule of thumbs I kind of like to throw out there for workspaces is one workspace per environment per Terraform configuration. So that's kind of how you see that laid out there. And the other thing is for workspaces and state files, if you're using the local version, like I said, that's just an independent state file on your local disk. There's no real teamwork there. You can't, if you want someone else working with you there, you'd have to somehow share that state file with them. It's no good. So we'll talk about how the Terraform Cloud solution fixes that, helps us with that. And then it makes it a shared resource so you can run it with a team and set some rules around that. But here's just a quick example of the language. So here's a nice little block of the HashiCorp configuration language. And what you're seeing here is 2 resource blocks. So there's a couple main ones. There's resource blocks, there's data blocks, and then there's module blocks. And there's a couple others, but that's kind of what the main thing you'll get is. And here you'll see at the top block is a resource for Azure. And it's a resource group. You're going to make a resource group called example resources in the West Europe location. The one below that is for an Azure availability set, and you're giving it a name, a location, what resource group is going to be made in, and then also tagging it as production. So that's what you'll see when you're writing it. I think it's very easy to understand. It's very, if you're not a developer, it's pretty easy to understand. If you're more of an infrastructure guy like myself, this was very easy to pick up and understand. So the next couple last pieces from the basics I need to talk about is the backend, the modules and providers. So the backend is the way the state file is stored, locked, and used. And there's a couple versions of that. Like I said, when you start off right off the bat, you're most likely going to be using a local backend. And that's, as I mentioned before, just a state file on your computer. But what you can do is you can set up remote backends. And if you don't want to use Terraform Cloud, that comes with its own backend. But you can set up, if you are using Azure or Amazon, you can set up, buckets or blobs and throw your state file in the cloud in a storage account. But what you need to be careful there is you want to make sure you have the right permissions on the account. You don't want it publicly accessible. You would like it somehow versioned or backed up. So when you're doing this yourself, you can set up a nice remote backend, and that's really the golden rule is you don't want a local backend with a local state file. You do want to set up a remote, whether that's yourself doing that in your own cloud or using Terraform Cloud. That's really what you want to do. As I said, the local is only good for a single user. It's not great. So the next thing is modules. So when writing the code, the modules are containers for multiple resources that can be used together. So you can write these, you can set up modules, you can use other people's public modules, you can write your own modules. But they're really good and useful for writing things that are usually linked together or needed. So that way, when you need to use them, it's very simple. So like a good example may be if every time you need to create a virtual machine, you want it on a brand new VNet and a subnet, something silly like that. You could create a module that you feed any necessary inputs you might want. Maybe you only care about what the V name is or the VM name is. So you'd write, you'd have a module and you'd feed it one parameter, the VM name. And that module would then go and create the VM. It would use the defaults you provided to create the VNet and the subnet. So it makes it very easy to set up this very complicated infrastructure with as little code necessary. And right when you start off, if you're not familiar with any of that, you're in the root module is what they call it. So that's where you're working most of the time, and you can nest your other modules inside of that. But the root module is where you start. And the way you use the language and create these resources as modules is you take advantage of providers. And during the demo, I'll bring up the provider page and we'll kind of go over what that offers. What the providers are plugins to interact with the other cloud providers, SaaS providers, any other API that is kind of manageable. And these providers, as mentioned here, define what Terraform can manage on that platform. Whoever that provider is, AWS, VMware, Kubernetes, these are providers that give you the ability to make and manage these resources. And there's a handful of different ones. There's the official ones provided by the big guys in HashiCorp. There's verified ones, and there's community ones. So I could write my own provider, throw it out there, and anyone could use it. It's probably not great to be using non-verified, non-official providers in your production code. But if you find something that's not out there and someone else figured out the problem for you, there's no need to reinvent the wheel there. So the next piece I'd like to talk about is kind of the life cycle and workflow of using Terraform. And after you're done, you got your code written. What you want to do is the first thing that you do is you run your plan. You say, I have this code. What does this look like when I run this? And the plan does a couple of things. It initializes your Terraform. It reads the config you wrote. It refreshes and reads your state to see what's out there. And it notes the changes, as I mentioned. That's all it does, is it's saying, this is what you have. This is what you want. Here's what's going to happen to get there. And once you have that plan, you would do what Terraform calls the apply command. And the apply command is, exactly what it says. You take your plan that you feed it, and it applies it all. It actually does it. And that is actually the execution of it. So it will go out there and start building your items, configuring everything, deleting anything that is noted in the plan. And the final thing you can do is you can actually destroy infrastructure using Terraform. So you can destroy everything in your state file. You can destroy specific resources. It's very easy to tear down and build up different environments very quickly with this tool and these simple commands. So now I'd like to compare the versions. Like I said, there is a couple different ones out there. Some provide a lot more than others. And really, what we're working with here is a free open source version that is really realistically you running Terraform on your local laptop or computer. You're running Terraform CLI commands. You're actually saying Terraform apply in your command line, Terraform plan in your command line. There's free cloud. And the cloud is their platform, their provided service that you're really using. And that really runs things for you. There's the paid cloud and the paid enterprise. And I kind of want to break down, where the lines are drawn here and what you get for each one. So at the infrastructure as code layer, all the versions get you the use. You can use your workspaces, you can use your variables, it'll provide you with resource graphs. You can use your providers, you can use your modules, and all of those across the board come with that basic level. But the next level, I think the collaborative and the support areas are kind of really where you see your big differences. So in collaborative, on the free open source one, as I mentioned, you can set up your remote state. You can use source control for your code, but this is all manual setup, and you got to really kind of understand what you're doing there to get a good working setup of a remote state using source control if you're doing it manually. And it can be done, and there's use cases for it. But I really think if you're going to try this out, you might as well try the free cloud version. It's free. There are some restrictions, but it provides a lot more for you. And as you can see here, it provides you source control connections or the VCS connections. You get a private module registry. You get a really good way to manage your workspaces, and you're able to provide secure variables for your code. The paid cloud comes with a couple more things. It comes with team management or role-based access control. So you can say these users have access to this workspace, and you can get more granular saying these users on that workspace can only run plans. They can't apply plans. So you can really grant, maybe your dev leads the ability to run the applies and not everyone, not anyone can just do that. Like having one person write the code, run the plan, and apply the plan, there's no peer review there. So that's not great. You really want some peer review going on. And a couple other great things that has built in that you can use is it'll show you cost estimations. And I have some screenshots coming up to show off what these will look like. But the cost estimations in your plan, it'll say, I'm building 10 VMs. This is what your cost is going to look like after I run this plan. And policy management is another big one that I really like. You can say any resource that you're needing to run, you can enforce policies like think based on cost. Maybe you say, don't build any resources that cost more than $1,000 a month. Or we can only use these VM images. I don't want any huge VMs. You can only use these ones. And I want to enforce, you need these mandatory tags on them. That's basic stuff that a lot of projects and companies do is they want certain tags or certain set of VMs. And you can set these policies right at the build time here in Terraform. And also at the enterprise. So the enterprise is basically the cloud version, but self-hosted. So you host it, you get a little bit of more discrepancy here. So what you can do is you self-host it. You can self-host your agent. You can set up SSO for your your enterprise systems there. You can set up auditing, and with the self-hosted agents, you can get more concurrent runs. You can kind of control your environment and how big and small you want it. The other couple of nice things is for self-service infrastructure, they have hooks you can set up to things like ServiceNow, where anyone can go in and request some sort of infrastructure, maybe just a simple VM or something. They can go request a VM in ServiceNow, and Terraform will take that workflow from there out and build that for you. So the final piece that you'll see changing across these is the support models you get. For the free version of cloud and the open source version, you're kind of stuck to community-based support, which is fine. It's a free software at that point, so you can't expect too much. But the paid cloud and paid enterprise, you do get tiers, paid tier support. So I think they call it bronze, silver, gold, and it kind of lays out SLAs and what you get for those support models. And that's kind of the differences you'll see in the support between the versions. Now, this photo right here is a picture of, in Terraform Cloud, this is kind of what the GUI will look like. And in the demo, I'll kind of go over the GUI a bit better. But this is what you would see if you had the cost estimation piece of this. In this photo, you can see they're creating an AWS, a couple of different instances, and a load balancer here. And it kind of breaks out your hourly, your monthly, and then your monthly change. And this is really cool because you can see before you even build these things, kind of an estimate of what you're taking on. And I know we have some talks this week on FinOps and how handling your finances in the cloud can be a pain, and how it's difficult with these resources to map costs to the resources, to the teams that are using them. And I think this helps you a lot more. Baking this right in here, you don't have to understand a lot of, they're doing it for you. And I think that's very nice to see. The next piece is a policy area. So this policy check, again, this is from the GUI. It's running a policy before you build. And this policy, as you can see, based on the name, is it doesn't want anything that costs more than $100 a month. So this policy checks what you're putting out there. It uses that cost estimation, and it says, okay, you're under $100 a month, I can deploy this. And then on the left side, you can kind of see what that looks like when writing your own policies. Is that one is just an allowed VM type. We allow these 3 VMs. If you don't match these ones, I'm not going to let you build this. And when it comes to policies, like many other ways you implement the policies, there's soft enforcement and hard enforcement. So you can have it where it's just kind of a warning saying, hey, we don't want things over $100 a month, but if you really need this, hit okay, and you can bypass this policy and you can build this thing. And you can set up permissions around who can do that, and that's very helpful. Or if you really have strict things, like you absolutely need tagging on all of your resources to make your reporting work, you just need tags. You can make that a hard enforcement and say, you cannot deploy this resource without these specific tags that we require. And those 2 things I think are a great selling point to why you might want to pay for the cloud version rather than using one of the freer versions. I think these 2 pieces are very, very important and helpful in large enterprises. So now I'd like to go to a demo and kind of open up the GUI and look at what that looks like, look at how you handle it, and go from there. So here, when you open up the cloud, the Terraform Cloud application, this is the kind of the main screen you'll see. As you can see, I have my workspaces here. And when you're working in the cloud, you can see your workspaces, you can see the status, you can see the repo connected. It's very simple to understand what you're working with, where things are, and what they should be. If you're using the open source version of Terraform, the CLI, to see this stuff would be, you'd open up your terminal, you'd run a command like Terraform workspace show, and you would see the ones you'd have, and you'd use commands to slip between them like directories. But the cloud really gives you a very user-friendly way to understand your workspaces, see them laid out you can filter based on what's going on with them. So, this GUI is very helpful, especially for people, that aren't, they're infrastructure people. They're not super familiar with using command lines to flop between their infrastructure directories. Like, this is very simple to use. So inside this workspace I made here, this demo workspace for Programmers Week, you get a lot of info here. So what you can see is your main overview page. It'll show your README from your Git repository. If you have a nice README, it shows you right here what this directory is doing. You can see your metrics for your average plan duration, apply duration, and a lot of good dashboards. I think a lot of upper management people, if you let them log in here and maybe not like run and apply things, I think they would really appreciate what they can see here based on what it provides. So the other great thing is it'll show you your runs. So when you trigger a run based on a code commit or manual trigger, as you can see, this one had no changes. So let me pick a new one. There we go. So this one added a resource, as you it's not just no changes. It actually had to add a resource. This was adding a new resource group. And it says, I want to add this resource, this is what I'm going to do. And then it applies and actually runs and makes that resource. And it spits out, where it was made, what it did. And then this is the other big piece I want to show off is the state files. So as I said, using a local state file is very tricky. It's not secure, it's not safe. So setting up these remote backends and these remote state files here, you can see it versions it for you. I can see this state file tied to this run based on this commit. And using your local setup or local state file, you're not going to get this type of detail. And this is really helpful with troubleshooting to see what changed in the state file based on what. And the other thing that this provides you with is because these state files are remote and ideally you have a lot of people working on them on maybe different teams, this provides a locking mechanism. So when it reads or needs to modify the state file, it can lock it, make it changes and unlock it. So if someone tries to do something at that same time, you're not getting any I guess you could compare it to like a merge conflict or something. You're not getting any changes at the same time that conflict with each other or override each other. You lock your file, you make your changes, and you unlock it for others to use. And that's built into this. Using your local, it's not possible. And setting up your own remote, you can do that, but you got to be careful. The other thing the cloud offers you is a nice variable page. If you're not using the cloud, you'd have this as it'd be a file in your directory. You'd store these variables in a file and use them. But this, you can add your variables to this workspace. You can make them sensitive, so no one can see them and it's write only. I have an example of that down here for a client secret. You can't see it. I don't want people to know what that is. I don't want it showing up in the state files or logging. It's very simple to use. So that's a little bit of the overview. I want to show some of the code blocks. So for this workspace, as you can see, it just is a couple of resource groups, and there's nothing crazy. So the code that matches this one, you could just click the commit right there. But it's this file right here. It's just showing I want these two resource groups, and it's very simple to use. These are the resource blocks, as I mentioned, but something bigger, you might see a lot. You'd see some data blocks, some resource blocks, some module blocks. It's a little bit more than what I showed there. So this is an example of what it might look like in the real world. And these are all using these providers. Terraform offers you all these providers. Like I said, there's official, verified, community, and these will show you, if you go to the documentation of the provider, what they give you examples and abilities to control. So let's say you want to deploy a CDN. Here you can see there's 3 CDN resources you can work with: the endpoint, the custom domain, and the profile. So let's say we need to make an endpoint. That is this block right here. It shows you how to set it up, the basic things you'll need, the name, the profile name, the location. And this gives you a great starting point if you don't know anything about deploying a CDN. This says this is how you do it, and it gives you a breakdown of what's required for what variable and what the value would be. So I think that's the documentation is very, very simple to use, and like I said, you don't need to know how to make a CDN because you have it right here. And that's kind of the provider aspect. Just want to show off a couple of these charts, and then we can go to maybe the Q&A. So these are provided by Terraform on their website. The one on the top left kind of shows you what languages you can use and have Terraform understand them and what it can spit out. So at the bottom, those are kind of the providers and what you can spit out. The middle is Terraform, and the top is what languages you can use. So you'll see HCL there. That's the main one I talked about. You can use JSON. If you work with Kubernetes, you can use custom resource definitions. And the newer thing is the CDK for Terraform. And that's where you can use maybe languages you're more of an expert in or more familiar with to run Terraform and build resources. And I believe a colleague of mine, Brian, has a CDK for AWS talk later today. If that's interesting to you, I suggest you check that out. The one on the far right is kind of a good overview of how the workflow is. So you write your IAC, you plan, you apply it, and then it spits out it uses the providers and spits out your resources. But there's also the community aspect where the community is writing useful modules that maybe they think other people need to use a lot. So you can take advantage of the community and really, not reinvent the wheel there. And then the bottom one is kind of a resource graph of what your configuration needs and what it does. So this resource graph shows, what provider it would need to take advantage of, what resources it would need to take advantage of to build the resource you want. And at that, I think if we have any questions.
Hey, thank you, Dylan. We don't have any questions right now in the chat, but we can wait 1 or 2 minutes.
Okay.
To see if some questions get in.
Sure. Okay. I can plug some of the other. I do have a couple of colleagues speaking later today in the DevOps community. Like I said, Brian's speaking on CDK for AWS, and I think Prasanna is speaking on best practices for DevOps. So if you have some time later, I would love for you guys to check those out and send them my love.
Okay, looks like no questions. We do have some reactions, so that's great.
Okay, that's good.
No questions.
I appreciate that. Thanks for everyone for listening. Can't see your faces, but hopefully you're entertained.